So for this question, what we will have is that L1 here will be having the same PD as your 1.02 because your galvanometer reads 0. So how do I know galvanometer reads 0? Because it said no current here. So this voltage equals to this voltage. So therefore, if you want the entire voltage, then it's equals to, it will actually take up the entire length. So we can use a ratio. L1 has 1.02 volts. So L1 plus L2, the whole voltage. So then we use ratio, and then we cross multiply, we will get the answer. So for this question, if you want to find the resistance of R, right, let's understand what's happening. Since the galvanometer reads 0, how do you know? Because they say balance point. So balance point means the point where your galvanometer gives you 0 reading. So remember, when the galvanometer gives you 0 reading, then the voltage across this test cell, which is in this case is a thermocouple, so just take it as another test cell, must be equals to this voltage. Then only the galvanometer will read 0. So in other words, if this is 6 millivolts, this also has to be 6 millivolts. So therefore, what about the whole voltage across the wire? So we can use the V is proportional to length. Since 0.6 meter is 6 millivolts, so 1 meter is how many volts? So we use the ratio. So how many volts across PQ? It will be 1 over, it means 1 meter. By the way, how do I know it's 1 meter? Because meter wire means 1 meter. So 1 over 0.6 times 6 millivolts. Then you get the total voltage across the wire, which is 10 millivolts. Then we also remember that the 1.5 volts driver cell will be divided between PQ and R only. Alright, so that means now we can use potential divider. So we know this voltage, which is 10 millivolts. We also know its resistance, by the way, is 5 ohm here. So treat this as a resistor of 5 ohm, the whole wire PQ as a resistor of 5 ohm, and it carries 10 millivolts in series with R. So use a potential divider means 10 millivolts equals to this resistance of the wire, which is 5, over the total resistance in series, which is 5 plus R, times the total voltage, and then you will get your R as 745. So in this question, it already balanced. At first, it's already balanced because it shows 0 deflection. But when we reduce the resistance of the variable resistor, remember the voltage of the cell divided between the variable resistor and the wire. So if this side is lower resistance, so the wire will carry a larger voltage. So therefore the PD across XY will increase, which is either A or B. But since you still want to use the same potentiometer to balance this test cell, now if voltage across XY has increased, voltage across XN will also increase. So it will be now bigger than the test cell, so we need to reduce the voltage. So how to reduce the voltage? We must move to make the wire shorter, so you must move towards X. So answer is A. So the first thing that you should do for this question is to recognize that since the current in your galvanometer is 0, whatever voltage across the thermocouple will be equals to this voltage, because the galvanometer is 0, whatever the voltage here equals to this voltage, so 6 and 6. So if this is 6 millivolts, the 2 volt cell will be divided between 3 now, 1, 2 and 3. So it's a potential divider that consists of 3 resistors. So therefore, if this voltage is 6, so 6 equals to this resistor, which is 3 ohm, they told you it's 3 ohm. So 3 over 3 plus 2 plus R, times the total voltage, then you get 6. So you can get the R as 995.